Hello students, welcome back to the next module of our chapter called electrostatics. Now students, in the previous module we have already derived the expression for energy stored in charge capacitor. Do you remember? Yes. Now students, in this particular module again we'll be continuing with the same concept and we'll be writing different expressions for energy stored in charge capacitor, right? So let us start. Now students, in the previous module we already know that energy stored, that is capital U, inside a charge capacitor or energy which is stored in a capacitor during charging is given by the formula U is equal to Q square upon 2C, where Q refers to the total charge and C is nothing but capacity of that particular capacitor. So I can say this is nothing but expression of energy in terms of charge and capacity, right? Now I'll be writing this particular expression in terms of C and capital V, where V represents potential difference, right? Now I'll be writing this in terms of C and V. Now if I want to write down this particular expression in terms of C and V, I need to replace capital Q, right? So for this particular case, I can write capital Q, it is equal to C into V, right? Where capital Q is charge, C is capacity, V is potential difference. Now I'll be placing this particular value of Q in the above expression. So what will I get? I'll get capital U, it is equal to C square V square upon 2C, right? Now see this particular expression. From this I can cancel out C and C square, right? So after cancelling C and C square, what will I get? I'll be left with capital U, it is equal to half CV square. So this is nothing but expression for energy stored in a charge capacitor in terms of C and capital V, right? Now let us move further and let us write down this particular expression in terms of capital Q and capital V, that is in terms of charge and in terms of potential difference, right? Now in order to write this particular expression in terms of Q and V, I need to replace capital C, right? What is capital C? It is nothing but capacitance. Do you know basic formula for capacitance? Yes, we know the formula and it is given by C is equal to capital Q upon capital V. Now I'll be putting this particular value of Q upon V in that above expression. So what will I get? I'll get U is equal to Q square upon 2, right? And instead of C, I'll be writing capital Q upon V, right? Now see this particular expression. I can cancel out Q and Q square. So after cancelling Q and Q square, I'll be left with capital U, it is equal to half QE, right? So this is nothing but another expression for energy stored in charge capacitor in terms of charge and in terms of potential, right? Now let us move further. So these are the three expressions for energy stored in charge capacitor. So therefore I can write capital U, it is equal to Q square upon 2C, it is also equal to half CV square and it is also equal to half QE, right? So these are the three formulas that we'll be using whenever we are supposed to calculate the energy stored in charge capacitor, right? Let us see one numerical which is based on the concept of energy stored in charge capacitor, right? Now it says a capacitor carries a charge of 6 microcoulomb at a potential of 500 volts. How much electrostatic energy is stored in capacitor, right? So let us analyze this particular numerical and let us write the given data, right? So capacitor is having a charge of 6 microcoulomb, right? So I can write capital Q, it is equal to 6 microcoulomb. Now there is a conversion factor from microcoulomb to coulomb and it is 10 raised to power minus 6. So this will become 6 into 10 raised to power minus 6 coulomb, right? Now this particular capacitor is charged at a potential of 500 volts, right? So I can write capital V, it is equal to 500 volts, right? So what I need to find in this case, I am supposed to find out the value of electrostatic energy which is stored in the capacitor, right? So I am supposed to find capital U, right? And the formula that I'll be using, that should be in terms of charge and potential. So the formula that I'll be using is capital U, it is equal to half QE, right? So let us start with the solution and let us write down the formula first, right? Now students, see the given data. Do we know value of Q? Yes, value of Q is known, right? So what is value of Q? It is 6 into 10 raised to power minus 6, right? So I'll be writing this particular value. So I'll get U is equal to half into 6 into 10 raised to power minus 6. I also know value of capital V. What is the value? Yes, it is 500 volts. So I'll be placing it over here. So this will get multiplied by 500. Now I'll cancel out 2 and 6. So 2 1 times and 2 3 times. Now 3 into 500 will become 1500. So this particular expression will give me 1500 into 10 raised to power minus 6, which can also be written as U is equal to 15 into 10 raised to power minus 4 joules, right? So students, in this particular module, we have learned different expressions for energy stored in charge capacitor. At the same time, we have also learned one numerical which is based on the same concept, right? So that's it for this particular module. I'll see you in the next module. Till then, keep learning.